this is the other half of what we already started, right? So those points combined with these points. Then technically you could add that times 1.2 on your multiple choice to see what you'd make on a mismatched years, but that's okay. Tomorrow we'll take the other half of that. Anyway, I'm not talking much through it. Train A runs back and forth on an east-west section of railroad track. Train A velocity measured in meters per minute is given by a differentiable function where time is measured in minutes. Selected values are given. Find the average acceleration of A over the interval. I started thinking I was doing a 1 over B minus A integral A to B. It is not that because I'm given velocity here. I'm not given the values of the acceleration, so I couldn't do that, and I don't have a function. So I had to go average acceleration A rock. That's all that was. So you've got the point 2, 100, and you've got the point 8, negative 120. You found A rock there, negative 120. Remember, you don't have a calculator. You could theoretically leave it right there. I did this, but make sure you have your units correct.
I did it upside down.
1 point. So you had to have everything right on that one, yeah. It was just the acceleration there. So that was the easy one of that, and I felt stupid because I kind of flustered on that one in the beginning. I don't know what I was doing. Part B. And anytime you see a question like this, you are looking for, chances are, IVT, MVT, EVT, one of those 3 or 4 theorems that we have, right? So does the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time between 5 and 8? That's your clue that that's what you're doing something between those two values. It's probably going to be some type of A rock between those two. And in this case, yes, it was A rock. Actually, no, it wasn't. No, it wasn't. You didn't have to do anything. You just had to look because this is asking you, is the velocity? Yeah, it has to be, right? If you go from 40 to, what did I go to, negative 120, so this is V of 5, this is V of 8, then it has to, but here's what you have to do. You have to justify correctly, okay? So 2 points for this one. Point 1, they wanted you to show, I lost this point because I did not show this. They wanted you to show that the velocity at, and I'm going to just put what they have so you, because I didn't do this again. The velocity at 8, which is negative 120, is less than 100, which that is less than the velocity at 5. Did I get that backwards? Which is 4. So they wanted you to show, and I think if you just did this, that would be sufficient. Or if you said it in words, negative 100 is between negative 120 and 40. So that's 1 point. The other point came from using the intermediate value theorem.
I wrote the word.
I would say yes. What did you actually say? Intermediate value theorem? Oh, the first point. You're talking about the first point. I think that's fine. Did you say from 40 or from? They want you to compare the 3. At some point, compare the 3 values, showing that the one value is between the other 2. That would be what I would say if I was reading this. Is do you understand that it's squeezed between the 2? Intermediate value theorem. They told you that it was differentiable in the beginning. Remember the caveats that go with these theorems. Most of them are differentiable and continuous. So for mine, I said, I'll just read you what I wrote because this was, the velocity is differentiable, therefore it is continuous. Thus, by the intermediate value theorem, the velocity must be negative 100 meters per minute sometime between the interval of 8 and 5.
What if I literally wrote like intermediate value?
Did you show the range of numbers for the other?
Yeah. For the other. And then like off to the left, that's true.
I would say I would say you probably get 1 out of the 2 points on that overall. I'd rather you grade yourself harsher than easier and then be used to. I think it really depends on your reader though. All right, part C. This was the hard one. I'm gonna be impressed if y'all got this one. I'm not gonna lie. This was actually a related rates problem, but didn't realize it until you really dug into it. All right, so a second train B travels north from the origin station. That's very convenient, right? The origin station. Here's your origin. All right, so train B is traveling north, so here's train B. And I had to draw a picture before it all clicked with me on what this was doing. This is the one I spent the longest time on. At time t, the velocity of train B is given by, and so then they have this. So the velocity of B is given by negative 5t squared plus 60 plus 25. Oh, dang, I did skip C. Okay, go up to C, sorry. I didn't know I did it on here. I just skipped over it whenever I... Okay, at time t equals 2, train A's position is 300 meters east. Remember yesterday I missed that one on that initial? I circled it on here, so I made sure. I hope y'all didn't miss that initial position. Or that 300 you had to add back in. The train's moving east. Write an expression involving an interval that gives the position of train A in meters from the origin station at time t equals 12. Use a trapezoidal sum with 3 sub-intervals indicated by the table to approximate the position of the train at t equals 12. Did y'all get this one? So you ignore, not the trap rule? You didn't get it? All right, so you ignore that first point because it says starting at 2, right? So I've got 2, 5, 8. And I didn't at first. Whenever I first started doing this one, I had to go back and erase that. You know how I do my little angles or trapezoids on here, and I go 1, 2, 3. I've got 4 intervals. Why do I have 4 intervals? Then I went back and read the problem again because that always helps, and it starts at 2. So there are my 4 trapezoids. So remember how you find the area of a trapezoid. It's 1/2 height times base 1 plus base 2. So because these are not all equally spaced, there's one different, I'm going to find the area of each individual one and then just add them together. That's easier for me. The height of this one is 3, so I got 3 over 2 times 140, base 1 plus base 2, plus, again, 3 over 2, 40 and negative 120 is 80. And then this one is 4 over 2, negative 120 and negative 150. Yeah. Let me write what I wrote on my paper. Negative 270. Theoretically, you could leave this just like this if you don't forget to go back in and add that 300. Okay. I'm extra. I always am, and it probably costs me points whenever I do it because I want to multiply it out and find out. But if you multiply all this, I cut these all in half first, and then I multiplied. That was the easiest for me. I came up to negative 150. I did, what did I do? Half of 140 is 70. 70 times 3 is 210. Negative 40 times 3 is negative 120. Half of 270 would be 135. Negative 135 times 4 minus, I got my little multiplication off to the side, plus 300. And then I added them all together. You lose just the one. So this was worth 3 points. You would lose the answer point. That's why it's a pretty safe bet just to leave it. If you can plug it in a regular, like 4-function scientific calculator, addition, subtraction, multiplication, division, you can leave it there. Dylan, what was Dylan's last name 2 years ago? Shelton. He always used to drive me crazy because I'd try to grade his stuff and he always left it like that. But I mean, he passed and he always, because that, I mean, you can. There's no sense in I'm just extra about. All right, so your point breakdown on this. 1 point for the. Oh, I did. it say? Write an expression involving an integral that gives the position of train A. So the integral from what I go from 2 to 12 of velocity is approximately, and I would just do this, the answer that I got. Right? Oh, no. What did it say? I must have skipped over this part. That is. All right, let me read it. Gives the position of train A and meters from the origin station. Okay. So this, what I should have done was just said, this is approximately all of this.
Right there.
Yeah. All right, so position expression, you got, oh, I see what they did. This is what they did. This was their integral expression. Position is at 12 is position at 2, that's your 300, plus the integral from 2 to 12 of velocity. Yeah. All right, 1 point for the trap rule, and 1 point for the sum.
Yeah, let's just say
That would be 1 point, because that negative 150, that's 1 point, because that's the position at time t equals 12. If
no,
you,
I mean the integral. You said the integral. I didn't do that.
the integral's not going to be equal to 150. The integral's going to be equal to all of this before. You have to do the integral plus 300 to get to the negative 150, because that's your initial position. This is just going to give you all of this. Does that make sense? All right, so 1 for the position expression. I lost that clearly because I didn't even read that part. 1 for the trapezoidal sum, and 1 for the position at 12. So 3 points for that one. The answer. Negative 150. All right, part D. The one I keep trying to get to. All right, again with part D. I know we're spending a long time on this one, but really this one I thought took really the longest for sure. All right, here's my train B. Again, B. That'll my work. Travels north. The velocity is given by, so this is the velocity of B, and it is negative 5t squared. I really have to lock in and write everything down, or I will lose where I am. Time t equals 2, the train is 400 meters north of the station. So right now at this figure, whatever I'm looking at, I'm at 400. And this is, then it says find the rate in meters per minute at which the distance between train A and train B. Whoa, I don't even have train A on here. What is train A and what is it doing? Train A leaves the origin station moving which way? East. Here's train A. At time t equals 2, what is the position of train A? 300. Do I also know the velocity of train A at time 2? Yes, I do. It's 100. That comes straight from the chart there. Now, I say all that because what they're wanting is what's the rate that that's changing. I called this C because it made sense to me if I had A and B to call this C. And so what I want is the rate that C is changing, which would be dC dt. Well, if you think about what I have A, which is 300. I have dA dt, because that's the velocity, that's just the derivative, right? Right. B is 400. dB dt, well, I could get that, right? Because I have an equation. So what's the velocity at 2 seconds? Negative 5 times 2 squared plus 60 times 2 plus 25. Negative 50, 120, 25. I got look at your work. That would make more sense. Okay. My work's all over the place. Which gives you what? Is everybody in agreement? Okay. What is C? You didn't do it. What is C? Could I get C? It's a 3, 4, 5 triangle. Pythagorean theorem. C's got to be 500. All right, so I say all that because I've got to figure out some way to relate them, and y'all have already said Pythagorean theorem. What? No, I got 160 meters per minute. That's what I got to. Okay, so a squared plus b squared equals c squared. If I take the derivative here, I get 2a dA dt plus 2b dt equals 2c dc dt. It's a related rates problem, and that's all. Let's see, and now it's just plug and chug. 2 times 300 times 100 plus 2 times 400 times 125 equals 2 times 500. This is what I'm looking for, is that dc dt. What's the rate that the distance between this changes? It's a 3, 4, 5 triangle, or you could do Pythagorean theorem to find it. I knocked a 2 off of everybody to start with. Remember, I don't have a calculator. I also divided everybody by 100. You could. You could. I got 300 plus 500. I divided all the sides by 100. You can do it out if you want to. You can leave it written like you would a calculator. I got 800 over 5. I left it like that. But I did throw my units on there. All right, breakdown for this one. This one was tough. It was a 3-pointer. Wait, this is so ridiculous. Obviously 1 point for the answer. The other 2 points come from implicit differentiation of distance relationship. In other words, nope.
What is it?
Gotcha. This one was tough. I'm very, very surprised that this was only a 3-point question. Part. No. No. Everyone said no. They said they love you very much, but no. What? Yeah. All right. Number 5. Y'all know I don't like to be mean. That's not mine. I never saw the that. I tried to save some paper because I run a lot of paper with y'all. All right, here we go. Part A, find the x coordinate of each relative minimum. I bet y'all can guess what I did. I did this.
Wait, was it x equals 1?
Yeah, because, all right, so I looked at every place the derivative was 0, which happened here. What? Well, because if you look, if this is negative, and this is positive. So by definition, it only happens when the sign changes.
I just looked at the one. I just looked at what y value is. You don't have graph it. Yeah, or you can just see what
Yeah. I have to do a sign analysis or I don't get it.
because it's negative. It's still going down.
Right, so just x values, but then you have to justify your answer. So here's what I did. I said f has a minimum at x equals 1 because the derivative, or f prime of x, changes from negative to positive at that point.
What if I just said at x equals 1, y equals 2, which is the lowest y value for f?
Let me read you there and you decide, okay? That you get 1 point for this one for the answer with justification. X equals 1 is the only critical point at which f prime changes signs from negative to positive. Therefore, f has a relative minimum at x equals 1.
That's not my justification, but I got the right answer.
Concaves up. You don't want to talk about concavity with nice men. You have to say sign change.
But I said
Did you say?
minimum. I said the lowest. It is the lowest.
That's what I said. I did say. How do you know that that's?
Look at the y.
But you don't know what's happening in the right.
You can graph.
How can you graph it? But just because this is 0 and this is 0 and this is lower, you don't know what's going on between here.
But I got the right answer.
It's just 1 point. This is just 1 point. No, that was the only part for A. It's just for F only. Yeah, it's just F only. There you go. Maybe they gave you a bonus. Ooh, I missed B. Explain why there must be a C. Why did I miss that? Explain why there must be a value C between negative, where C is between -1 and 1, such that the second derivative is 0.
I said there's no change between f prime.
It's MVT, y'all. It's mean value thing. Did you put that? Shut up. Well, I missed it. All right, so you got a point for that. So it's mean value theorem. They didn't give you any second derivative, right? So what they wanted you to do was go, okay, the first derivative at -1 is 0. The first derivative at 1 is 0. If I do the derivative of that, right? So I'm going to use A rock to estimate I rock or see what's happening. So 0 minus 0 over -1 minus 1, which is 0. Therefore, if the average rate of change on that interval is 0, then the instantaneous rate of change must be 0 somewhere on that interval by the MVC or by the mean value theorem. I would think you would have to show, they say your 1 point comes from that, and then the second point comes from explaining mean value theorem. every concave doesn't have a minimum of every concave. Say it again. If you what? I understand what you're saying. But I do understand what you're saying. I agree. Because right, 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 right. I agree.
Are they taking this to grade it, or are there like three justifications that they looked up?
I don't think that they think through a lot of things like that. Like they're not going to look at it and go, I know. They won't look at it and go, I know you could do this with algebra, but because they're looking for the calculus.
That's how some of our probabilities relate to that.
Right. Yeah. Right.
I thought I got it right. But if they told me I had six,
Right. And that's what they anytime they ask for a max or min, always talk about change of sign. Always. Yeah. All right, part C. Ooh. All right, I thought it went much better after we got through number 4 and then A and B of B of number 5. Things started getting a little better. I thought. H of x is defined by the natural log of f of x, and it said find h prime of not x but 3. So to start with, I did do the derivative of h, not at 3, but just the derivative. So I'm in a chain rule type situation here, right? Derivative of log is 1 over x, so I do 1 over f of x, and then I chain it. Okay. You got a point for that. Actually, you got 2 points for that.
For what?
2 points for that, for finding h prime of x.
I put 1 over 7.
As hard as these others are, you got 2 points just for taking the derivative correctly. This was a 3-pointer. Your answer was 1 point on this one. So the answer was once we plugged in.
Is that 1 over 7?
This is 1 over 7. This is 1 over 2. So it's 1 over 14.
I didn't get that.
That's fine. I think that's fine. Yeah. Don't do that next time, though. Make sure you write it out. But I think that's fine. Because does it still say h prime of x, or did you change that x to 3 as well? So they get picky about that kind of stuff because this is actually not a derivative. So what I would do is I'd give you those points, but I would write it twice. Listen. I'm so paranoid about what they take points off for because I have literally heard them say before that somebody put an equal and it doesn't equal. It was an approximation and they took the answer point away. So I'm super. I know. Part D, evaluate the integral from -2 to 3 of, all right, so 2 different ways. I actually worked this one twice because I was trying to think about the way y'all would think about this whenever you solve it.
What's the final
-6. Oh. So yes, this is just chain rule in reverse. So if I think about the antiderivative, and this was the first way I did it, I said this is just f of g of x evaluated from -2 to 3. Is that the way you guys did it? Okay. You could also think about it being a u sub problem. If you let u be g of x, then du is the derivative. And so I end up with f prime of u, which if I take the antiderivative of, I just end up with f of u, which is f of g of x. Anyway, I worked through both ways to make sure that I could explain it both ways if you did one of the other two ways. But I thought this was the easiest. I still don't have a point yet though, because you don't get your point until you do this. This is worth 2 points right here, the fundamental theorem of calculus. Yeah. I'd give myself a point for that. And then the answer, once you plugged it in, you had to look at the table, you had to find G of 3, and then you had to find F of that. It ended up being F of 1 minus F of negative 1, which ended up being 2 minus 8, which ended up being 6. They said 1 point for the answer, 2 points for the fundamental theorem of calculus, where you subtract it there. Yeah. We have 3 points for the whole thing, 1 point for the answer, 2 points for the fundamental theorem. Did good. It's amazing. It's awesome. All right, I hope you ate up the slope field. I'll just show you the picture so you can see. Yeah, you just trace the line. The second loop kind of, well, see how the slope gets steeper here? So it's kind of, it probably need to go a little deeper, I think. That's only 1 point.
I mean, I think I got it right.
All right. Again, Miss Ray, I don't know what I was doing. Do what?
Why is yours so deep?
That's not mine up there. Mine wasn't quite that deep. This is mine, this is theirs. I didn't go quite as deep as they did. I guess I did.
They actually look that close at it.
They literally did it wrong. It's supposed to go through 0 to 1.
No,
it's way up here.
I
you
did
did it
do
wrong.
it wrong. I put it through the wrong. Yeah, I lost my point on that. I didn't look at there.
I
It's
didn't
hard to
realize
see
that.
where the little dashes are there.
No, but it's
Yeah,
supposed to
you're
be
right,
on the,
you're right, you're right.
I didn't even know it, right?
You're right. So we all need to be careful of that. All right, part B. Yeah, let's go. Write an equation for the line tangent to the solution curve in part A using the point 0, 1, and then use it to approximate f of point 2. And so I have this dy dx up top, 3 minus y cosine x. That is the slope. If I want the equation of a line, I need a point and a slope. I have a point, I have a slope if I just plug in here, right? So 3 minus 1 times the cosine of 0, which is 2. Cosine of 0 is 1. So the slope is 2. So my equation of my line, y minus 1 equals slope times x minus 0. You could leave it there. I tend to solve it for y. You don't have to distribute. This one was a 0 there, so it didn't matter. There's my equation of my tan line. I think that was a point. That was 1 point. Yep. Then, if you plugged in the point 2 to this equation, which would be 0.4 plus 1, which is 1.4, there is another point. So 1 point, 1 point. That's fine. That's fine.
The answer, but I did the wrong thing.
Answer's still worth a point. Yeah, the answer's still worth a point. All right. Part C, y'all. If you have kept up with the points, how many points do you think part C is worth? 6 points in part C.
Wait, what?
All right. This is why I stress to y'all all the time, write something right. Are y'all still stuck on this one? What are y'all talking about?
No, he thinks you got it wrong, but you got it right.
Robert said you got it right.
Look at the right side. Y minus 1. X minus 0.
Yeah, you can do that or that.
You want to know how I got the slope distribution?
How?
I traced the graph, or I looked at
No,
the.
you didn't.
No, I did.
Oh my gosh.
And I drew a line up here, and it was like about 2.
Did you not see the differential equation in the beginning of the problem?
Yeah, but I didn't know what it was. What'd you do? Plug
Okay.
in something?
The differential equation is just the equation for the slope, because it's the derivative.
But what do you plug in? 0?
It said 0, 1.
Yeah, but the slope. Oh.
So whenever you get the actual one, and you'll see tomorrow, everyone's on a different page. For the most part. All right, proceed. But that one I run exactly like you would see on the test. So tomorrow's will be exactly like you see on the test. All right. Fine. This was the hard part, but this is why I tell you, make sure you do something. Do not leave anything blank. With a 6-point question, my gosh, there's room to get points everywhere. All right. Find the particular solution when I have this point. If you, it's an equation, yeah. If you solve this, what's your first step in solving a differential equation? This is a guaranteed FRQ. Separate the variables. Get the x, the dx with the x's, get the y with the dy's. So I divided by 3 minus y, so I got dy over 3 minus y equals cosine x. Yeah. That's fine. That was a point. Already. Separating the variables gives you a point. I have never seen an FRQ that you did not get a point for at least separating the variables. So if you ever see dy dx and they say find the particular solution, if you have no idea what to do, at least separate dy and dx and get them on either side with the other variables. You'll always get a point for that. Then integrate. Thank you. Now this is a negative y here in the bottom, so this is going to be, if you think about a u sub kind of situation, right? But this is going to be negative log. Because, all right, if I let u be 3 minus y, then du is negative dy. If I let u be 3 minus y, then du is going to be negative y, because that y is negative. Anytime your y is negative over here, you got to think chain there. Antiderivative of cosine, no, positive sign. This gives you 2 points. It says 2 points for the antiderivatives. I am going to say, if I was reading this, I would probably say that's 1 and that's 1 to make up the 2 points. But listen to this. This is the crazy part. That's a point for giving the plus c, the constant of integration. Even if you got the rest wrong, if you knew you had to put that plus c there. Maybe that's where you solved and found the constant of integration. It just says constant of integration. I think that's where we solved and found c. No, because that's using initial condition. Yeah, you get 1.5 plus c. They won't do that for this. They'll do it if you like go from like A to B and you use your answer from A for B, but with an. Now it could be. I'm assuming no. That's what I've always been taught is no. I can ask Mark on our little chat. Okay, let's continue to solve. This is kind of a hard solve. So at this point, I went ahead and plugged in my 0, 1, and I solved for C. I found it easier to do that here. Negative log 3 minus 1 sine 0 plus c. So I got negative log of 2 equals that 0. Is that right? I actually took this negative off before I divided this by negative. I have a positive log 2. I guess it really doesn't matter. Ugh. I did this on mine so that I didn't have to work with all those, because if you whether you add the constant or not, it really doesn't matter, but it still goes away. That's what I have. I don't know what I'm doing with this. But yes, it's still okay. Regardless, it's still negative log 2. All right, show my equation. Okay, still haven't got any more points. Nope, I did. If you plugged in the initial condition, even if you plugged it into the wrong one, I'm going to assume give yourself a point. If you use 0, 1, used the initial condition to solve for c, whether your equation was wrong, everything else was wrong. If you plug 0 in for x, 1 in for y, and then you solve for c, right, Robert? Then you've got a point. See, y'all gonna start turning your phones back in. Okay. I know, that's why I'm having to explain it. All right. Yes, no, maybe so. You get a point for plugging in 0, 1. Okay. All right, that's my C. So I'm going to go back into this equation, and I'm going to say that the log of 3 minus y equal to negative sine x minus the log of 2. Now it's just a solve. Three minus y equals. I left this. I didn't. We talked a long time about splitting up the e. This is not multiple choice. I do not have to format it any particular way. I went ahead and subtracted 3 here. I left all this because I really could care less at this point. I was done. This is question number 6. And I did divide by negative, and I moved that positive. I switched them around, but that's just personal preference for sure. All that, which I think is crazy, was only 1 point in the end for your 6th point. Now here's the caveat with those as well. You cannot get more than 3 points if you did not include the constant of integration. If you never separated the variables, you get 0 out of 6, period. That's a little note on the bottom. All right, put your score. Yeah, look. Note 0 out of 6 if no separation of variables. Okay.